I think a chipper would be fun.
Okay,
Just
so
like chip it.
when we're working with paper and drawing compasses and stuff, does it work up here? I mean, can you see what I'm doing if I zoom in enough?
Yeah.
It's a little harder over here. Okay, so I think that's what I'll do.
I like it more when it's on the board.
Do ya?
Yeah.
Let me try that way, we can always go the other way if we need to. So let's start out, we're gonna, like whole sheet of paper, we got lots of this paper. You have to give yourself an X and a Y or X and Y axes, and maybe put Y the long way.
It should be so rich and pencil. Where did they all go?
Yeah, I know, that's a good question.
Is that what you said? Use the whole sheet?
Are you doing the big board or the electronic one?
I'm gonna go here.
I think I stole your favorite compass.
Oh, I have lots of favorites.
I don't think that's how favorites work.
What did you say, Xander, that was funny?
I don't think that's how favorites work.
That's not how favorites work, is having lots of them? Yeah.
Mr. Can I have a question?
Sure,
What's your favorite number? Did I already ask you
I have
that?
lots of favorite numbers.
But like, number one.
Yep, number one.
You don't have one?
I do. Let's see how this, so this, I've got X and Y. Let's do this. We're gonna work up, do you remember the quadrant numbers?
Yeah.
1, 2, 3, 4?
Yeah.
1, 2, 3, 4 counterclockwise, starting up here.
Yeah.
One of those tres, cuatro. You may do them like Roman numerals, but, so let's go up to number 1. And then what I think I'd like you to do, triangles. Yeah, we don't have a lot of time. You want to get your quizzes back, right? So let's make a triangle up there. For the lack of being creative, let's call it ABC. And let's orient it clockwise. And let's make it semi-unique and put the vertices on intersections of integer coordinates. There's 8. I don't care where you put yours. I'm gonna do mine like this.
Could we draw it crossing one of the axes?
Just make sure your vertices are at the intersections. Okay, so that we don't make it too complicated. So you can orient it any way you want. I don't care what it looks like.
Can it be in any quadrant?
No, let's start in 1. This time let's be less than creative and start in 1.
Okay.
And then, you guys remember composition of reflections? Reflections, you know, like remember like if you had a composition of two functions, like t composed with s, what has to happen first?
S.
S, and then you do
T.
t, so that's t composed with s. So if I wrote, we were gonna do a reflection, and that reflection was gonna be over the x-axis, oh boy, of triangle ABC. And then it would be, oops, I'm sorry, I'm going bad here. It'd be a reflection over the x-axis of a reflection over the y-axis of triangle ABC. Is that written right? Reflection over x?
How did you?
You do the y-axis first.
Yeah, it'd be the y-axis first.
Yeah.
Is that right?
Yes.
Okay, good. So we're going to reflect over y, and then we're going to reflect it over x. And the way I'd like you to do it is I'd like you to take triangle ABC, and I'd like you to map it onto, that's what the arrow means, map it onto, put it onto, so on the graph, you're gonna put it onto a triangle, A prime, B prime, C prime. And then the final, let's call ABC double prime. So we have two reflections, right?
Go over Y, then over X? Is that what you said?
Yeah, that's the way this would be, we would do that. We would reflect over X, the reflection over Y.
So we start
We go,
with.
we reflect over Y.
Yep, so Y gets done first, and then you go over X.
Since you have graph paper, you don't have to construct everything.
Yeah, you don't have to do this with your drawing compass if you don't wish to.
Can we use a ruler?
Please, yes.
You could use your ruler, you can use counting. Yeah, I mean, if you wanna use your drawing compass, just work really fast.
Snowball.
You need everything, don't you?
I was rushed this morning, so I forgot to put my back.
Yeah, that's a pretty lame straightener. This is a better straightener. Which one of these was? I'm trying to remember. Oh, not really, This isn't even that good. All right,
Yeah.
I get it back though, okay? Those things have been not coming back.
Think about all the different million things that we've done in this chapter.
Could make a butterfly if I made an heart and down and this way, flood. No. I'll show you, I'll make a butterfly. I'll show you.
And then when you're ready, come up and grab some tracing paper if you need it. I don't know how much you have.
Do we need it? Oh,
Yeah.
we need it for this thing. Thank you.
Someday we're gonna run out of it. It's getting there all of a sudden. Jeez.
Doesn't really, okay, body kind of short.
That's fine with me. I think you're doing a wonderful job, pal.
Oh, yeah, Cheryl?
Uh-oh. We're running out. I'll take those. It'll work. You don't need a whole lot. We got moose gall now.
Oh, no, no.
Are we there? Feet. Thank you. There's a lot of dog crap outside. You step in it and you put it up on there and then somebody else does stuff, that's not good.
I mean, Crocs are pretty clean, I gotta say.
I know, still.
They're looking pretty good.
Okay,
They
so
may have been a bit longer.
here's all we need to do. Need to make a rough tracing of your pre-image. And then call it A, B, C. Label it.
Is it okay if I just say straight and people
It is what it is, right? Okay. Now, if we don't pick up our tracing paper, like, there's two reflections, right? So you flip it over, you got your tracing paper upside down. You flip it over the other axis, and now the tracing paper is right side up again. So without thinking about flipping your paper over, what could you do to move that image to the pre-image? Rotate it. What would be the center of rotation? Like, I don't know if you remember in middle school, we did some of this stuff, if you were here at least, where you put your pencil down and then you would spin the tracing around. Maybe we did that this year, I can't remember. Yeah, we did it again this year. So where would you put your pencil, the tip of your pencil, if you were gonna spin this around and get it to go from the pre-image to the final image location?
Yeah, the origin, yeah.
The origin.
Yeah, the origin.
So, you got this all pinned out. Put your pencil on the origin, give it a turn.
Oh, magic.
It should end up down there.
My triangle is too big, it's always not too big.
I'm sorry.
Yeah. You should have done that.
Hey, Mark, look at my
So-
triangle. It's archy.
How many degrees is it? 180, so it's a half turn, isn't it? All right, so if we come back to this, just doing a little bit of, you know, if we came down like this, you don't have to draw this on your paper, but that's 180 degrees total. And, you know, we could do all kinds of things. I need a ruler. I feel like a magician pulling rabbit after rabbit out of the hat. Eventually those rulers are gonna run out. But, looky there. From A to A prime goes through the origin. From B to B prime goes through the origin. And so does C to C prime. Everything crosses the origin. Now, we reflected over the X and the Y axis. How many degrees is it between the X and the Y axis?
Yeah.
How many? It's 90, isn't it? It's a right angle. So what we have here are two perpendicular lines. And we take this image and we rotate it 180 degrees. This is 90, the rotation's 180. What's the relationship between 90 and 180? What's the relationship between 90 and 180? 90 is half of 180. 180 is twice 90. It's so nice that you guys multiply and divide. few years ago when I asked you questions like that, you say, well, you have to add 90, well, you have to subtract 90. Now we're up to multiplication and division. This is great. Okay, do a sheet of paper. Or you can flip it over. I'm not, because I got lines all over that read right through. X and Y axes.
Same thing, whole sheet.
And then, you're going to put a different line on there.
We're just putting a line on it.
Well, in a moment. We're all going to put the same line on, I hope. Just waiting for everyone to be caught up and ready to go. So where does that line go?
Straight through the origin, right in between that, right at a 45.
Goes through the origin at a 45. What's the slope? What's the y-intercept? 0. Yeah, this is the same as y equals 1x plus 0. So increasing or decreasing? Increasing, so the slope is positive. So let's put that on here. Be careful with it. Get it as close to accurate as possible. And maybe label it. Oh, that's funny. It looks black, doesn't it? It's really red. That's okay. So that's the line y equals x. Okay. Okay, this time I'd like you to try to mimic my triangle, okay? Let's just do this. So,
Yeah, it's pretty hard to see.
okay, A is going to be 1, 2. B is going to be, you're right, it is kind of hard to see, isn't it? What do I want to do? I want my other one. Oh, shoot. Well, let's see, 1, 2, 3, 1, 2, 3, 4. 3, 6 is B. And C is 1, 2, 3, 1. There we go. Can you read that, or is that too small?
B is 3, 6.
B is 3, 6, yes. Alright, so, let's see. We're gonna reflect. We're gonna reflect triangle ABC over y equals x. And then we're gonna reflect that image over y. And what I would like you to do is keep track of where things go in terms of the ordered pair of the coordinates.
So it says reflect over what? Y equals X?
Yep.
And then over Y?
Yes, first of all over the y equals x, and then take that image and take it over the y-axis. You can do it numerically if you want. You know, whenever things reflect, it goes at a 90-degree angle, right? So, gosh, I wish I could make this lighter. For some reason, I don't know. It doesn't allow me to make it lighter and darker, I don't think. That's pretty sad. But anyway, when A goes over the y equals x line, it goes at a 90-degree angle to y equals x. And y equals x is on a 45-degree angle, so you ought to be able to go 90 degrees to that. So this, I think, comes right down here. If you look at that, this is the line of reflection.
And then over Y?
I'm sorry, y equals x is the line of reflection, and this is the direction. So just take it, just get triangle A prime, B prime, C prime first, and fill in the ordered pairs.
You could make a good start. Like that.
It's like a snowball.
And fill out the ordered pairs, like the note table that I did there. You get started.
Oh. Yeah.
Yeah, everything should be. Because if you're on the grid and your lines are just like spot on through the intersections and everything.
We're supposed to shave that? You know, I don't know. Maybe? I don't know.
Yeah, fill out the ordered pairs also.
Instructions are not
It's up there.
clear.
Yeah, A for A, and then the ordered pairs 1, 2, those are the coordinates. Got coordinates too?
Yeah. Do you want us to shade it?
I'm sorry?
Do you want us to shade it?
I just did that so you could see it, but you can see yours.
I hope so.
Color the pencil if you want. Get her back. That's not that long enough. We're doing it that way. Doing it all pro. That's good.
No.
We put the order pairs in for the first image. What does A prime become? 2, 1. What does B prime become?
6, 2,
And C prime.
1, 2,
So what do you notice between the pre-image and the first image?
flip flop.
X becomes Y and Y becomes X. Because we're reflecting over the Y equals X line. So now X equals Y and Y equals X.
Wow.
Yeah. Like a big concept that we're going to expand upon a lot. Not as much this year, but next year, and the year after, and the year after, and the year after. Okay, now, what are, I don't have mine done, do I? Are you guys done with yours? So in this case here, B prime ends up here, right? So what are the ordered, or what is the ordered pair for B double prime?
-6, 3.
-6, 3. And what about A double prime? What did that become? -2, 1. And C double prime becomes -1, 3. So we put all this together, going from here to here, Y equals X and X equals Y. And then going from that to that, we reflected over the y-axis, and what did that change for our ordered pairs?
The X values became negative.
The values became negative. In other words, they became their opposite. Because instead of being right of the y-axis, now we went left. And if you were left and you were right, when you jump back and forth over this, you're just changing your x values. What do you think happens when you reflect over the x-axis? You change your y values. So if you look back at the first one that you guys worked on, do the same thing. Except with your table, just go right to A double prime and B double prime. Don't copy my numbers, your triangle's different, I think. Take a look and see what happens to both the x and the y values.
They get multiplied by -1.
They get multiplied by -1. Both of them, don't they? Because when we reflect over the x, the y's change sign. And when we reflect over the y, the x's change sign. So when you do a 180-degree rotation, you're changing both the x and the y to their opposites. Reset. You have a protractor? So with that reflection over y equals x and then over the y-axis, determine the magnitude of rotation.
Over the y equals x.
This one here, when you went over the y equals x and then over the y, determine the magnitude of rotation for that composition of two.
Just 90.
Does it look like 90? Remember how to do that?
Looks like it to me.
What's our homework?
I don't know yet. Still 2 minutes to go. I got time. I'll think about it real hard and fast. Let's make sure we have this one though. So how many degrees? 90. So if we look at the y equals x line, which is here, that's one line that we rotated over, reflected over, and then we reflected over the y-axis. So what's the measure of the angle between y equals x and the y-axis? 45. 45 times 2 is 90. Here, we reflected over y and x, which was 90 degrees between the two. Twice 90 is 180. So if you have lines that cross at a 20-degree angle and you rotate over both of them, it'll go 40. And it doesn't matter whether you go forward, or you reflect back and then forward again. It still comes out that you double the angle between the lines. You can do a long shot. Without using a DGS, but using graph paper, try question number 23 on page 215. Question 23 on 215. Yep. No crying.
What's a DGS?
Oh, digital geometry system. It's using a computerized system.
Well, I didn't even know what that was, so.
Yeah.
What was the page again?
23, I think. Did you say 23?
Page 215, number 23.
Is that cool?
question mark for the R1 homework question.
Oh, yeah, I'm looking. So, when are we gonna work on? a
Can
couple
I
of
come
these?
in tomorrow?
After school?
Yeah, or would that work?
Yes, that will work,
Okay,
yeah.
tomorrow then.
Do you want it or to like have her quiz?
No, I looked at it and I gave you feedback if that's good enough for you.
Yeah, no, that's great.
Okay.